Everybody, back with another video, hopefully the last in this little Space Invaders. I had a couple board sets to repair. This one has some sound issues, and it also has some graphics issues, if you can see that right there. And if I hit, let's say, Space Invaders, let's see. You can see it flashing and missing some text or characters. And it's definitely got some weird, graphics glitches or something going on. And you can see it's missing text, like by free play. Alright, so back looking at this, it's been a few weeks actually. I haven't had time to really mess with it. Whatever, let me get my solder out of the way. Okay, so powered on the board, I have it hooked up to the Fluke. If we look right there, and right there, we have our lines on the screen. Whoops. We have our lines on the screen. And we should have basically 16 lines. And it should be basically one line, 2 blank lines, and then I think 4, then 10 blank lines, 1 line, 2 blank lines, 4, 10 blank lines, 1, you get the idea. And there's basically 16 of these vertical stripes, and the RAM obviously looks good. This is when you run the board without any ROMs in it at all, like I'm doing right now with run unit under test. But what I'm going to do is I'm going to actually do a RAM long. And I'm going to show basically what it looks like. Let's see if I can do this here, because you can start to see a little bit of the craziness. I'm going to turn off the lights. See if you can see that. And you can see the weirdness that's going on. The RAM is fine, but there's some type of interference or something going on there. I just don't even know how to describe what I'm seeing. But we know that in this board that the video accessing, the RAM is shared between the video and program data. So there's these multiplexers. There's address multiplexers that are addressing the CPU address bus, as well as the video, what I like to call the video address bus, the stuff coming from the counters. There's the video address bus and the program address bus. Those are multiplexed together, and then the data outputs are, I guess, are they multiplexed? I don't know. I have to look at the schematic, but like data going back to the CPU goes one way, and data goes back, goes to the actual video output a different way. And I'm going to show that on the schematic. But at this point, what I'm going to do is I'm just going to let this run, this RAM long test, because you can see the weirdness when I'm running the RAM long test, because it's writing obviously certain data to the RAM chips, all different types of data like FFs, 55, 00, 01, and that's what the RAM long test does. I'm not going to go into that, but you'll see that when it's the video address bus accesses that RAM, and from a timing standpoint, what it's the video circuit outputs what's in that RAM, you get to see this on the screen. And so I'm just going to let it run, and then I'll come back and speed this up, hopefully, so you can see everything. Like right now, see it's going, it's just writing probably 00, I guess, because that's black, I guess. And it, hopefully we still have it. Let's see. Can I zoom in? Test is complete. RAM Long's good. Okay, so hopefully you guys can see this okay. Basically, you know, you have your address bus that goes into the RAM. Here's your RAM over here on the right hand side, right? And you have your timers, which are your 9316s, or I don't know what they were, 74 or whatever we replaced them with. And so there's a lot of stuff that the timing circuits, right, it does besides generate 160 hertz and 15.k horizontal hertz. They also do things like set enable pins and do like addressing of the RAMs, and that's why I like to call it the video address bus, but I think I got that from Williams or somebody else, I don't know. Anyway, you can see here that you have these 9332s, these multiplexers, which are 74 157s. They're the same as 74 157s, and you can see that some of the addressing comes from, like if you look at right here, you know, comes from this 9316, which is basically just the counter, which is also, you know, like 120 hertz or 480 hertz. It's like your 32V and your 128H and stuff like that on the horizontal counters, I mean, or your sync counters. And so that comes in, and so you have two inputs on these Muxes and then one output, and that is what gets addressed to the RAM. So when the RAM, my understanding is when it's being enabled, whether it's for, you know, data going back to the CPU, you know, is dependent on which mux in the timing here to see which data you're getting, because all the data just goes out onto the bus. And then the video data comes to the 74 166 that we had previously replaced, and it comes up here, goes through this resistor, comes down here, and is basically ultimately your video out, right? So the RAM data, the data just goes straight off of this into the 74 166, gets combined, and there's your video, you know, going out to the screen. So I don't know exactly what's wrong. It could be like something going on with these Muxes on the addressing side, or it could be something coming outbound, but I would think that the out is okay because we know our RAM, we're able to, you know, the CPU is able to put data into RAM and get data out of RAM 100% fine, because it, you know, it comes out the same, like this E4, the 7404 is the D4. All of that is the same and is shared, whether it's the video address bus addressing the RAM or the CPU address bus addressing the RAM. All that's the same. So that's why I don't. It's either some enable or something, or it's these Muxes is the only thing I can think of. So I basically hooked up my logic comparator, and the Muxes are at E or F4, 5, 6, and 7, and this one was already replaced. F7 was replaced previously. I can look underneath of it and tell that it was replaced. It is a 74 LS 157, whereas these other ones I believe are the 9322s. And if you see here, I have on this F4 chip, output 4, 7, and 9 are all bad. And you can see there, it's still got bad screen stuff going on. Alright, so now let's come to the next chip. Whoops, just reset it. Reset it. Alright, power it off. Damn, it doesn't even give me a signal on this. There we go. Okay. And this one I have output 9 looks bad. Oh, And maybe 9, 10, 11, 12. Is 12 an output as well? Oh, there's 12. Yep, 12 is an output as well, and it's kind of hit or miss there, based off of what's going on the screen. Alright, and then let's check this one here. Now we got 4, 7, and 12 on that one. And if I go to the last one, it looks good. So either, you know, there's some timing or there's just some chip differences between the 93s, the 9322s, I guess, and the 157 that I have in here. I don't know. I don't know why those are reading differently than my chip. Doesn't necessarily mean they're bad. Actually, let's power on the scope and just look at the signals of all those outputs. So we're just going to go first chip. 1, 2, 3, 4. And I'm just going to hold it right there. Okay, that's 4. Right there. We're just running through a track mode right now. That's 4. That's 7. I mean, these look pretty decent. This is 9. Now, there's definitely some noise on this thing that looks weird. I mean, look at the tops of that right up there. I don't know, that looks kind of odd. Let me slow that down a little bit. Or maybe let me speed it up. Maybe that'll be better. This is 0 volts and 100% is 5 volts. So we're looking at F4 pin 9. Yeah, you can't really see. 11, 9, 10, 11, 12. Oof, what the hell's going on with 12? Well, 12 might actually not do anything. 9, 10, 11, 12. Just high. Is it changing? Yeah. I don't have a good signal. Wacky. Alright, well, let's go to the next chip. Pin 4. This is F5. F5, pin 1, 2, 3, 4. Yeah, there's quite a bit of like a little noise there at the top. I don't know if that means anything or not. Pin 7. There's noise there. Pin 9. I gotta press pretty hard. There we go, 9. Interesting. 10, 11, 12. Alright, and then we come to F6. 1, 2, 3, 4. 1, 2, 3, 4. 7. Not terrible. 9. 1, 2, 3, 4. This is the 74 157 that looked fine. 7. Alright, there's pin 7, pin 9. I guess there is, whoops. I guess that little noise or that stuff going on at the top there is okay, I guess. I don't know, at least on my scope. So I don't know if that's our problem. I know it's showing bad in the logic comparator, but that could just be the difference between my 74 157 that I have in here. I don't know. I might look some more before I start going ahead and trying to swap all those out. Probably won't hurt anything to swap them out, it'll just be work. But I have my doubts that that's going to fix anything. Alright, just to make sure, because I was probing around off camera, went and got out the other board that I was working on, and it also has 9322s in there, and my logic comparator looks good. If I can get this on there right. Yeah, you can see that. There's no weirdness going on. So I guess I will go ahead and replace those. I also found something else wrong with my other soundboard, but I'll come back to that later. I guess that's my best guess right now. I mean, it does look like my comparator reads this board fine on the outputs there, so I'm going to do it. Alright, I have 3 new 74 157s in there. I have my doubts on whether that's the problem or not, but let's see what we get. Yeah, I can see it's still screwed up. I had a feeling that wasn't the problem. Still jacked up. Where is my... Absolutely no difference at all. And I know it's not the bit shifting or whatever that goes on the daughter board, so I don't know what the hell. But that doesn't look right. Alright, so I'm back at this, and this guy on YouTube that watches my channel mentioned that he thought, based off of a previous video I did on fixing the audio, SenilyDeluxe, thought that 32V was missing from the counters. And so I have written this down before, and these measurements were taken from a different board, but you get the idea. Like 128V is 60 hertz, 64V, and this is pretty much the same, I think, on like all games. 64V is 120, 32V is 240, 480, so on and so forth. Ignore the other digits. That's just exact measurements I took. So then I went and looked at the schematic and was looking at my counters. E7, pin 11, 12, 13, and 14. And so let's start there. This is E7 right here, pin 14, pin 11. 9, 10, 11 is 60 hertz right there. Let me adjust my seconds per division down a little bit. Right there, 60 hertz, right? And then 120 hertz and 240 hertz, right? 1, 2, 3, 4, and then 480 hertz, if you can see that. Okay. So again, pin 11 was 60 hertz right here. Whoops, did it reset or something? Pin 11, 60 hertz, which is 128V, 64, 32, and 16. Right, 16V, 32V, 64V. I just want to see if SenilyDeluxe, how close he was, because I'm already onto something. But that goes to, on the address bus, video address bus, as I was referencing, pin 14 goes to F7 pin 2, 32V F7 5, 64V F7 11, F7 14. F7, which is right here, pin 2, and we got 480 hertz, which is correct. And then we want to go to pin 5, 3, 4, 5, and we have nothing. That's not good. Then we want to go, which is actually the 32V, by the way. So SenilyDeluxe seems to be on to something. Then the other thing we want to go to is pin 11. So that should be 9, 10, 11. And we have nothing. And then if we go to pin 14, we have our 60 hertz. So basically this chip right here, this multiplexer, is missing some of the video address lines, and it's probably because of a bad socket job on this chip here, which I might be responsible for. I'm not sure, can't remember. Or it could be because this chip was removed as well, and it could be something bad on this side. I'm not sure. So I'm going to have to investigate what's broken or run jumpers or something like that on those lines. All right, the ones that I needed to jump were E7 pin 13 to F7 pin 5, E7 pin 12 to F7 pin 11. I just ran a couple little mini clips there real quick. Let's power on. See what it looks like. That's looking better, I think. Much better. So I got my joystick connected. Hopefully my audio's working somewhat. And we just start a game. Looks good. So that was our problem. So I need to fix this. Okay, good. I need to fix that. I don't know. I need to maybe pull that socket out or something. I'm not exactly sure. I'm going to figure it out, the best way to fix it. But obviously I need to do some jumpers, or I need to do some trace repair. Alright, it's looking good. I got everything back together, as you can see here. I didn't really have to do anything except for just resolder those joints, I guess. And it is working. With one hand here. So that's it for this video, guys. Thanks, SenilyDeluxe. 32V was missing, as well as, I believe, 64V. So, anyway, thanks for the hint.